Hello everyone, my name is Michael Lewis. I'll be working a dynamics problem focusing on the application of Newton's second law. So here we have a problem that states the 10-pound block has an initial velocity of 10 feet per second on a smooth plane. If a force F, which is 2.5 t-pounds, where t is in seconds, acts on the block for 3 seconds, determine the final velocity of the block and the distance of the block travels, during this time. So here's what was already given. So I began to go ahead and jot down a few more givens. Fw, which is a 10-pound block weight. V naught, which is 10 feet per second, which is the initial velocity. And so I need to add the force, which is 2.5 t. And that is the force exerted on the block from 0 to 3 seconds. And also we can't forget the frictionless force, so which is UK, which equals 0.25. So we were asked to find the final velocity, which is V sub F at t equals 3 seconds. And the position, which is XF. Final distance. The block travels at t equals 3 seconds. So the first thing that I would recommend you do is your free body diagrams. So let's fix it right quick. Let's start off with the forces. So I have a block. And so I have a force acting here. I have the weight of the block, Fw, acting here. And then we have our normal and tangential forces, which is Fn acting here, and then the force acting here. So from here, I can go into my coordinate system, go ahead and establish exactly where my x and y will be positive or negative. So I'm gonna establish the regular coordinate system. X this way will be positive, y this way will be positive. Then from here, I'll establish my IT, which is my initial terms. So I have a block. Force is here, m times AY, and then m times AX. So we have that established. I put my swigglies around there so I can stay focused on it. So from here, I'll start summing my forces in the y direction, which will be this way is positive. So what you'll do, you look at all the forces that you have going in the y direction. We have Fn, which is going up, and then we have Fw, which is acting down. So I would do Fn, which is positive, minus Fw equals m times AY. So we know that Fn minus 10 equals 0. And plus, we don't, in the y direction, we don't have any, it's not being elevated, it's not going up, so we can actually set it to 0. And then just do the simple calculation, we know that Fn equals 10. So we have our forces in the y direction. Now we can work on our forces in the x direction. So we have F minus FF equals m times AX. So from here, we mainly want to go ahead and solve for AX since we have those numerous forces. So we know that this will equal 2.5t minus 2.5 equals 0.31 equals 0.31 over 0.31. So I know you're probably wondering why I calculated 0.31. So let's go back right quick. These are a few terms you know that you probably want to do for future reference on the side. So we know that FF equals K times FW, which is 0.25 times 10. Calculate that, you get 2.5. And also, we know that FW equals mg. From there, you do FW divided by G equals M. So we have 10 pounds divided by 32.2 feet squared, and they give us 0.31. So from here, this value will give us 8x. Give you time to look at that. And then just to simplify just a little bit more, all you have to really do is just 2.5t over 0.31 minus 2.5 over 0.31 equals 8x. So once you simplify this, you'll end up getting 8.06t minus 8.06 equals 8x. So we can use this equation that we just came from for 8x and then start integrating to solve for our velocity and position. Since we're given 8x, we'll do A equals dv dt, fundamental forms. So we're going from A to V to S. So we're going backwards. So A equals dv dt. And so we're going to clean this up a little bit. We're going to do A dt equals dv. So from there, we'll just integrate. So we have V naught to V dv equals T naught to T AX dt. Go back in and plug in. What you do to one side, you must do to the other. So now we can plug in 8.06t minus 8.06 plus 10. So now let's take our limits. V minus V naught, that will be V minus 10 equals 8.06 t squared divided by 2 minus 8.06 t plus 10. And we're calculating t at 3 seconds. So once you go back in and plug that in, you'll just get VF equals 22.09 feet per second. So now we have our velocity. We can now find the antiderivative of this so we can end up getting our position. So let's go back and plug in again. We'll use the fundamental form V equals ds dt that has the same relations. So V dt equals ds. We take our limits, s naught to s, ds equals v dv. As you can see, s naught to s, ds equals t naught to t, 8.06 t squared over 2 minus 8.06 t plus 10. So we still have our S to S naught, which equals 8.06 T cubed over 6 minus 8.06 T squared over 2 plus 10. And once you plug in T equals 3 seconds, you'll get the position, which is 30 feet. And now you've calculated the